Hi. Now if you watched the earlier video on the roots of a cubic equation, you'll know that I showed you that a cubic equation had this particular form in terms of its roots. And what I want to do now is just give you an example where we form another equation based on the roots of a previous cubic equation. And to do this, I've got this example here. The cubic equation 4x cubed minus 2x squared minus 3x plus 1 equals 0 has roots alpha, beta and gamma. And we've got to find the equation with roots 1 over alpha, 1 over beta, 1 over gamma. Now at this point you might even want to have a go at this as part of your revision. If so, just give you a moment to pause the video and do fast forward to the end if you want to check your answer quickly, because I'm going to take you slowly through the method and work solution. Okay, welcome back then if you had a go. Let's see how you got on. Well, if you look at the form of a cubic equation in terms of its roots, then with these new roots 1 over alpha, 1 over beta, 1 over gamma, our equation is going to take on this form. X cubed minus the sum of the reciprocals of the roots, that's going to be 1 over alpha plus 1 over beta plus 1 over gamma, times x squared. And then we've got the sum of the products of pairs of roots, so that's going to be 1 over alpha times 1 over beta, that would be 1 over alpha beta, plus 1 over alpha times 1 over gamma, so that's 1 over alpha gamma, plus 1 over beta times 1 over gamma, that's 1 over beta gamma. Alright, so we're going to need to find that. And we've got the product of the roots, okay, minus the product of the roots. So if we multiply those roots together, we're going to end up with 1 over alpha beta gamma. So we need to find these values, and to find those values we've got to go back to the basics of what we know about the connection between these roots and the coefficients of the equations. If you watched that previous video, you'd know that if we compare the coefficients of the cubic equation that has this form, you can see that A's 4, B's minus 2, C's minus 3, D equals 1 when we compare it to our equation up here. And we found out that the sum of the roots, alpha, beta plus gamma, equaled minus B over A. The sum of the product pairs was C over A. And the product of the roots was minus D over A. So it's very easy to put these values in. We get a half, minus 3/4, minus 1/4. And so with these values here, we should be able to now determine the values of these terms here. So let's start with 1 over alpha beta gamma, because that's going to be the easiest here. If we look at this result here, clearly 1 over alpha beta gamma, it's got to be 1 divided by minus 1/4, which is going to lead to minus 4. So if we look at the product then of the new roots, 1 over alpha beta gamma, we put our values in, we end up with minus 4. So we've got this value here. Let's work out this one here, the sum of the new product pairs of roots. So looking at that, okay, we're looking to find this value here. And to do that, we could put this all over a lowest common multiple, that'd be alpha beta gamma. And if we work out the numerator, what we're going to get is gamma plus beta plus alpha, then all over alpha beta gamma. And we can now substitute our values in for the sum of the roots. We know from up here it was a half. We know the product of alpha beta gamma was minus 1/4, so putting those values in turns out to be minus 2. And lastly, we've got to do the sum of the roots, okay, the new roots here. And we'll be looking then at working out this value here. And again, put these fractions all over a lowest common multiple, work out the numerator. What you get is this result here. In the numerator, we've got the sum of the products of the pairs of roots. It turned out to be minus 3/4. So we've got minus 3/4 then divided by minus a quarter for the product of the roots, and working that out comes to 3. So we've got all our values now for these terms here. So if we substitute those values in, we get our new cubic equation with roots 1 over alpha, 1 over beta, 1 over gamma. Okay? Now, that's all very well. Take my word for it that this is the cubic equation with the roots of 1 over alpha, 1 over beta, 1 over gamma. Now, we never actually physically worked out what those roots were, and we don't have to get this equation here. But what I want to show you is just to verify that this is true through a graphical method. So here you'll see those two graphs. The graph then of y equals 4x cubed minus 2x squared minus 3x plus 1. And this is the graph here of y equals x cubed minus 3x squared minus 2x plus 4. Now remember, the roots for this equation here, when it equaled 0, were alpha, beta and gamma. That's where it crosses the x-axis at these 3 points here. Clearly you can see this one is 1. But these other two turn out to be, let's just put them in, minus 0.809 and 0.309. I've called them alpha and beta, and I've let gamma be the 1. So when we do the reciprocal of these roots, we would hope to get these results that you see here. And indeed we do, as we've got here. Do check these out. You'll see that 1 divided by alpha here gives us minus 1.236, which agrees with this point here. Clearly 1 divided by 1, well, that's going to be 1. And 1 divided by beta, this value here, turns out to be 3.236. So there's just a graphical visualization of what we've just done. So I'll take you back now to the final screen just so you can remind yourself of that working. So here's the workings back again, and hopefully if you had a go at this you were able to get it right. If not, at least hopefully you've been able to get an idea of how we tackle problems of this nature.